Welcome everyone. We are kicking off a brand new series where we're going to break down the UP PGT economics question papers from previous years.
We're going to start with the 2011 paper, and in this first part, we're tackling the first 10 questions. So if you're ready, let's dive right in.
Okay, first question up. If the slope of the demand curve is less than the slope of the supply curve, what will be the nature of the equilibrium?
Your options are A, stable, B, unstable, C, static, or D, dynamic. Have a think about it. The real key here is that relationship between the slopes of the two curves.
And the correct answer is A, stable.
So why is that?
Well, it all comes down to something called the cobweb theorem. It basically says that when the supply curve is steeper than the demand curve, meaning it has a greater slope, the equilibrium is stable. This just means that even if prices in production bounce around a bit, they'll eventually settle back down to the equilibrium point.
All right, let's move on to question number 2. Which of these statements is the right one when a consumer's income goes up?
Let's see what we've got. A, because of an increase in income, demand increases. B, because of an increase in income, demand expands. C, there's no change in demand. Or D, none of the above. Now, you really have to pay attention to the wording here. What's the difference between an increase and an expansion in demand?
The correct answer is A. This is a really fundamental idea when we're talking about normal goods. See, when a person's income goes up, they can afford to buy more stuff, right? This causes the entire demand curve to shift over to the right, and we call that shift an increase in demand. An expansion, on the other hand, that's just moving along the same curve because the price changed.
Okay, our third question is diving into consumer theory. At the point of satiety, what is the marginal utility? Your options are A, 0, B, positive, C, maximum, or D, negative. Just remember, the point of satiety is that sweet spot where you've gotten the absolute most satisfaction you can get.
The right answer is A, 0, and this graph shows you perfectly why that is. Look at the top curve. That's total utility. You see how it peaks at point H? That's your point of satiety. Now drop your eyes straight down to the marginal utility curve below. At that exact same quantity, at point M, marginal utility hits 0. Pretty cool, right? If you keep going past that point, your total utility actually starts to fall, and marginal utility goes negative.
All right, question 4 builds right on that idea of satisfaction. When is a consumer actually in equilibrium?
The options give us a few different formulas to choose from. Is it A, when the marginal utility of X equals the price of X, or B, when the ratio of marginal utility to price is the same for goods X and Y? Maybe C? Or could it be D, all of the above?
The correct answer here is B. This is what we call the law of equi-marginal utility. It sounds complicated, but all it really says is that a smart consumer will spend their money in a way that the marginal utility per dollar they spend is equal for everything they buy. You can think of it as getting the most bang for your buck from every single dollar.
Question 5. Gosson's first law is popularly known by what other name?
So, our options are A, the law of demand, B, the law of diminishing marginal utility, C, the law of equi-marginal utility, or D, none of the above. These are all huge, foundational concepts in economics.
And the correct answer is B, the law of diminishing marginal utility. Gosson's first law just states that as you consume more and more of something, the extra satisfaction, that marginal utility, you get from each new unit starts to go down. We've all experienced this, right? That first cookie is amazing. The 10th one, not so much.
Next up, a question on the revealed preference theory. What is this theory all about?
Let's have a look at the options. Is it related to A, strong ordering, B, the economist P.A. Samuelson, C, the analysis of consumer behavior, or is it D, all of the above?
The correct answer here is D, all of the above. And what's really fascinating is that this theory was developed by the Nobel Prize winner P.A. Samuelson. It's based on an idea called strong ordering, but the most important part is that it analyzes what a consumer actually does in the market, not just what they say they prefer. It's all about observation.
Okay, let's switch gears to indifference curves. The question is, for complementary goods, what shape is the indifference curve?
Here are your options. A declining straight line, B, an inclining straight line, C, a curve that's convex to the origin, or D, none of the above. Try to picture goods that go together, like, say, coffee and sugar.
And the correct answer is D, none of the above. Now, why is that? Well, for goods that are perfectly complementary,
think a left shoe and a right shoe. The indifference curve is actually L-shaped, or a right angle. This shape shows us that you have to consume these goods together in a fixed ratio.
This next question is really just testing the exact same concept. Which of the following statements is correct?
And once again, the answer is D, none of the above. Let's look at the table to see why. The statement about complementary goods is wrong. We just learned that their curve is L-shaped. And the statement about perfectly substitute goods is also wrong. Their curve is a straight declining line. So neither of those original statements was correct.
Now for something a little more advanced. Under Slutsky's substitution effect, what happens to the consumer? So, does the consumer A, stay on the same indifference curve, B, move to a higher one, C, move to a lower one, or is it D, none of the above?
The correct answer is B. The consumer moves to a higher indifference curve. I know, it might sound a bit counterintuitive, but in Slutsky's method, the substitution effect actually shifts the consumer from a lower curve to a higher one. Let's use this graph to see exactly how that works.
Okay, let's walk through this step by step. First, in step 1, the consumer starts out happy at point Q on indifference curve IC1. Then in step 2, the price of good X falls and they move to a new equilibrium at point R on a much higher curve IC3. That whole jump from Q to R is the total price effect. But here's the important part, step 3. Slutsky's substitution effect is just the piece of that movement from Q to S. And as you can see, point S is on a new curve, IC2, which is definitely higher than the original one, IC1. So this effect actually puts the consumer on a better, higher indifference curve. And for our final question in this part, what does the Engel curve actually express? Is it A, the price consumption curve, B, the income consumption curve, C, the average cost curve, or D, the utility curve?
The correct answer is B, the income consumption curve. It's actually pretty simple. The Engel curve just shows us the relationship between a consumer's income and how much of a particular good they buy. It's a great way to see how our spending habits change as our income changes.
And there you have it, the first 10 questions from the 2011 UP PGT economics paper. So, I have a question for you. Out of everything in consumer theory, which concept do you find the most difficult? Let us know. We'll see you in part 2 with the next set of questions. Until then, keep on learning.